Very good day everyone. We welcome you to the massive open online course on cartographic techniques practical. Today we will be discussing about Isopleth and Choropleth mapping. So far we have studied about georeferencing, we have studied about digitization, then you have been working with symbols and labels. We will be starting to work with a few thematic mapping styles. So we will be starting with the Isopleth and Choropleth mapping. So the content for this lecture is going to be what is an Isopleth map, then what is a Choropleth map, then what are the procedures to develop a Isopleth map using QGIS and a Choropleth map using your QGIS, and then a few points to remember in this whole process. Now, what is an Isopleth map? I think you would have already studied this in your manual technique. So what is your Isopleth map? So it is generally used to visualize continuous data. So that is the first thing, our first use of Isopleth maps. So continuous data, when we talk about continuous data, it is generally your temperature data, your elevation data, your rainfall data. All these information will fall under continuous data because these cannot be discrete or these cannot be unique. It is continuous throughout the surface. So that is why we call it as continuous data. And the thing is, when we talk about continuous data, the best data model for that is actually the raster data model. So most of the data sets that we use in Isopleth mapping, the base will be a raster data model. And now how it is being done, or how is this Isopleth mapping being done? That is done by trying to connect lines of equal values. So when we draw lines that connect locations with equal values, so that is how we do this Isopleth mapping. So we try to draw lines that are connecting the locations having similar values, and we will just see a small example for that. So you can see this image here, and you can see the values 150, you can see the values 160, you can see the values 170, and you can see these lines moving around. And so what these lines represent is, this particular line is having an elevation of 150 throughout these locations. So we are joining those lines and we are trying to create a Isopleth map. Now the next case of Choropleth map. So what is this Choropleth map? A Choropleth map is a basic thematic map in which we generally use polygons in it. So the polygon features are being represented in a nice way for some kind of understanding, and we will see what kind of understanding it is. So the values of the polygons are being shaded with the help of, like, in terms of proportions it is being shaded. So a good example will be related to your population density. So generally for Choropleth mapping we try to do it with polygons. So polygons we take, and if we have the information of the population density, we try to distribute that value in equal proportions, and we try to see where there is high density or where there is a lower density. So it generally, what it does is, it helps us to understand what is the clustering or patterning in a particular group of data. So where there is a higher density of population, where there is a lower density of population, and why there is a higher density, why there is a lower density, is there any kind of clustering around that place. So all these things, all these pattern based studies, Choropleth map forms the ultimate base. So this is a small example of a population density map. So you see that there is a small clustering over here, then again you see a kind of very lower density in this region. So today what we will be trying to do is actually create this Choropleth map, and today we will be trying to create this Isopleth map. These two maps we will be now trying to create, and there is a small procedure for it. So first I will just quickly explain you the procedure of the Isopleth mapping. So in terms of Isopleth mapping, what we are going to do is, basically like I said, there is a raster data set. That raster data set we are going to bring it inside QGIS. We are going to use the contour tool to generate the Isopleth map, and then after that we will be doing some parameter settings, then we will run the tool, after which we will try to alter the symbology using the graduated symbols, and then we will alter the label and we will generate the final Isopleth map for our required output. So, with that being said, I will quickly jump into the software part. So, now you can open your QGIS. So, the QGIS folder, then QGIS desktop 3.40.9. You can click on new empty project. Now, we are going to add a raster data set. So, you can click on layer, then you go to add layer, and then you go to add raster layer. So, you can go to your respective folder where you have kept your data, and you can find this TIFF file, which is Pune_DSM. DSM is nothing but it is a digital surface model. It represents the elevation of a particular region in the form of gridded pixels, which is your raster data set. So, Pune DSM, you can select it and you can open it, and then you have to click on add to add it to your map space. And one more thing that you can also do is you can click on your web, then you can go to your quick map services, you can search for QMS, and you can search for your you can type in your Google satellite hybrid here, and you will get the required satellite data base, and you can add it to your map space. So, I am adding it to my map space. It is just for a reference, it is just to know whether my data is sitting properly, and also it is to kind of have an understanding of what it is, where we are, and to interpret few features. So, when we have such a good base map, then our interpretation can also improve along with that base map. Okay. So, now I have brought my raster data inside. The next thing I am going to do is I am going to go to my processing toolbox. I am going to go to my processing toolbox, and in the search bar you can try to type in contour. Once you type in contour, you can see the contour tool being displayed over there. You have to double click on it. Once you double click on it, there is a small window that gets opened, and you can find that the input layer is already automatically being added to the window. So, you see that Pune DSM is the raster data set for which we are going to generate the Isopleth map. So, Pune DSM, I am selecting it as the input layer. Then the next thing is, what is the interval between my iso lines or my contour lines, what is going to be the interval. So, the interval that I am going to give is 50 meters. So, that is the interval that I am going to give, and once I generate a output, now the thing you have to understand is this output will be in the form of lines, and these lines, so like we discussed earlier, it will be a layer and it will contain n number of features, and every line will represent a particular elevation value which is continuous. So, you have to give an attribute name for that elevation value. So, I will assign it as height over here. So, for a basic Isopleth map, these three things, the what is the input raster, then what is the contour interval, and what is going to be my attribute name. If I just mention these three things, these three parameters are more than enough. So, once I do this, what you can do is you can save your file. So, I will just show you that again. So, you have to click here, then you have to go to save to file, and then you have to just save it in your desired location. So, I will just put a new folder, output, and then make sure that you give the file format as .shp shapefile. So you give the file format as shapefile, and then you can name it Isopleth, and then you can save the file, and then you can run the output. Okay. Then close this particular window. Now in the layer panel, so I hope you all remember the layer panel. So your layer panel, you will see your Isopleth layer being added. So now you have actually generated your Isopleth layer. Now I will slightly zoom in and I will try to show you. Okay. So you see here, this is actually your Isopleth that is being generated from the tool that you have run. Now quickly we will do two things. One is we will try to symbolize this so that we are able to interpret from it, and the next thing is we will try to add a label to it. So these two operations we will do now. So first the symbolization part. So like your previous classes, you would have heard about the graduated symbols. So we will be trying to use the graduated symbols here. So you go to symbology, then on top you have this icon of single symbol, in which you will go for the graduated symbols. And once you come to the graduated symbols, it will ask you for the value based on which my symbols has to be graduated. So for that you click on this value, and I hope you remember we set the value or attribute name for the particular output as height. So I am now selecting that height over here, and then I am just selecting this symbol and improving the thickness to 1.0. So the first thing is you have to change it to graduated, and then you have to select the value based on which the graduation should happen, and then the symbol thickness you can increase, and also the color ramp we can go for a darker and a nicer color ramp just for our understanding. And the classification, I think we will keep it as default, and we will go for equal interval method classification. Okay. So 5 different classes. So we have values from 0 to 280, 280 to 560, 560 to 840, 840 to 1120, and 1120 to 1400. This is basically trying to represent the elevation. So from the mean sea level, what is the elevation of that particular place? So that is what it is trying to represent. So once I have given classify and I can give apply, now you can see here the colors being applied. So now what you can do is you can just switch on this satellite hybrid layer. Okay. And we can also try to reduce its transparency. You have to just double click on the Google satellite hybrid. In the properties you have to go to transparency, and in that you can adjust the transparency of that particular layer. So you can adjust it. Now you can see the features. So now here you can clearly see this is a nice hilly terrain, and you can see that the initial heights are 560 to 80 in the bottom part, the green line, then it gradually increases to 840 to 1120. So the line, so this is the range. Now if I say I want to know what is the exact height of that particular line, what is the exact contour height of that particular line, if I want to know that, we can try to label it. So for labeling it, it's very simple. What you have to do is you have to double click on this Isopleth layer, and once you double click on it, you go to labels, and in labels you go for a single label, and next to that you get an option called as value, in which you have to set the height. So when I set it as height, whatever value is there for that particular feature, the height value, that will get displayed here. And a few things that you can do over here is you can kind of increase the size, then you can try to go to your placement option and you can select on line, so that it sits exactly on top of the line. So you can go to placement and you can select on line. And the next thing you can do is add a slight buffer around your text, so that it is clearly visible, it can be clearly differentiated. So I will give a slight yellow over here, and then I am going to apply this. So now you can see the values also for each individual line. So you see here it is 700 over here. Then, so I hope you remember we gave the interval as 50 meters as the interval. So based on that, these lines are being drawn. So along this line, the height is going to be 700 meters. Then the next line, it is going to be 750 meters. And what we learn from is that this terrain, it is rising in its height along this direction, similarly from here and similarly from all these directions. So this is your small demonstration of an isopleth mapping. Okay. Now we will just quickly move to our choropleth mapping. What are we going to do for our choropleth mapping? So we are going to basically open a vector data set, and that is going to be a states data set which has the information of population attached to it. And after doing that, we are going to open the attribute table, and after opening that, we are going to do two things. One is we are going to calculate the area of every feature, which is basically the area of every state, and then we are going to do the calculate the population density, which is basically your total population divided by your total area of each state. After this, what we will be doing is we will again do some work with symbology. Again we will be touching upon graduated symbols, then we will do a slight labeling, and then we will wind it up. So with that being said, we will just quickly go for the choropleth mapping. And before going to the choropleth mapping also, I quickly wanted to show you one thing alone. So the isopleth layer that you created, if you open the attribute table, you can actually see the n number of features that are there, and you can see the height attribute given to every feature. So I wanted to show you this because you need not wonder from where this height is coming. It is basically from the attribute table. So when you started with the tool, you set the attribute name as height for the output. So that height is being attached here. So you can see these values here, 700, 650, 650, 50, all those values you are able to see it here. Okay. So I will just remove these layers now. So right click, remove layer, and I can also remove my raster data set, remove this layer also. So first thing, I need a vector layer which is my India underscore states underscore population. So add layer, go to add vector layer, and when adding a vector layer, you can go to state wise population, India underscore state underscore population, and I hope you guys know that we have to choose .shp file, and then you can give add, and you can just right click on this, and then you can zoom to layer to see the entire layer, and then we will right click, open the attribute table. Now in the attribute table, you have the name of the state, then you have the code, and then you have the total population. So now we are going to just work with this total population. So first thing what we will do is we will try to calculate the area of each feature. So one thing I wanted to show you is, see, I can select here, let us say Gujarat. Okay, I am selecting it here, and then you see here Gujarat is selected over here. So what you have to understand is that in the attribute table, every row represents every feature. So, in the attribute table, every row represents every feature. So, that idea you should have. What we will do now is, you see this pencil icon on top. So, you first click on that pencil icon, which it signifies starting to edit this layer, and then you can see the from the last the fourth icon. So, this icon here, the fourth icon. So, that is your open field calculator icon. So, when I click on it, you can see that it is the field calculator. Now, what I want to do is, I want to create or I want to calculate the area of each feature. So, what I will do is, I will create a new field, okay, and the output field name is going to be area, okay, and the output field type is going to be decimal, and the precision is going to be 4. So, you have to create a new field in which you are going to add the area, and then you have to choose what is the name of that field, you have to choose what is the data type of that field, and then you have this space where you can put in an expression here. Can you see? So, this space is where you put in something called as an expression. So, what expression are we going to put over here? I will tell you. In here you can see this option called geometry. You can see a list of options over here, out of which you have something called as the geometry. You can open it and then you can go down to find area. You can select this dollar area, not area, you have to select dollar area. So, you have to just double click on this. Now, you can see a preview value in the bottom here. Can you see? There is a preview value over here in the bottom. Now, this preview value, from the preview value, what I can understand is, this particular output that is being calculated, it is being calculated in square meters, but in terms of density it is always better to use your kilometer square. So, what I do is, I just calculate the area and then I divide it by 1,000,000,000. So, this is like converting from square meters to square kilometers. So, once I do this, then my area field will get created with the area in square meters, and a good habit is to always save whenever you do a single operation. Also have this habit of saving your edits. Now, the next thing that we want to do is quickly create a population density. So, again we go to the field calculator, then again we create a new field, and then this time I will name it as population density, and the output field type I am going to keep it as integer and not decimal, because when we talk about population density, it is always in whole numbers. 100 people per square kilometer, 200 people per square kilometer, you cannot have 200.5 people per square kilometer. So, we keep it as an integer, and the expression here is going to be the formula that we saw, which is basically your total population divided by the area. So, how do I do this? That is the question. In the same way you did for geometry, you come to this list over here, you will find this option of field and values. So, see here you find this option of field and values. So, here you will double click on the total population and then divided by the area. and you can apply it, and then you can give OK. Okay. So, it gets added up here as population density. So, now the raw data that I require or the data to do my Choropleth map I have prepared over here. So, just to recap, to get the population density you need the area. So, we are using field calculator, you are using the geometry option $area, calculating the area, and then you are using the total population divided by area to get what is the population density. So, now the next stage is going to be your symbolization stage, where you double click on the layer that you want to symbolize, you go to symbology, and then you go with graduated symbols. So, graduated symbols you select. So, value. So, in the place of value you are going to input population density. Once you have inputted as population density, the next thing is going to be my color ramp. So, I think we can go with reds. So, reds is a nice color ramp Choropleth map, and after doing that, one important thing with Choropleth mapping is, now how do I split the classes. So, now today what we will try to do is, we will try to have a low, medium and a high density of population, 3 different classes we will have. Before defining or before deciding the range of values, from which value to which value I am going to give as low, from which value to which value I am going to give it as medium, which value to which value I am going to consider as high, before deciding that, it is always good to explore the histogram. So, you can see this option of histogram over here. See, this is the option of histogram over here. Now, this histogram you can load the values, and you can see that bulk of the information or bulk of the data, you can see it found over here. So, based on this I will assign a range which you can try to follow, and we will do the finalize the mapping. So, this histogram will help you to find or tell where there is a good grouping, and based on that grouping you can do the clustering. So, for classification we can also go with natural breaks, and you can try to classify it based on the natural breaks also. You can see that good groupings are created around the bulk of the data, and then few outliers are also being considered. So, for us we are going to work with 3 different classes. What we are going to do now is, we are going to just symbolize this, assign a value for this, and we are just going to symbolize it and visualize the Choropleth map. So, you can just quickly assign a value like this, where I will keep the lower value from 1 to, let us say, somewhere around 250, okay, then 250 to 500, and anything above 500 is going to be my high density. So, you can change it here like this: low, medium, then you can give this as high. So, once you do this, you set the symbols, you set the values, you set the range, you apply, then there comes out your Choropleth map. You see the grouping here, you can see a medium grouping found here, and again in the south Tamil Nadu and Kerala kind of showing a bit of higher population density. So, with that being said, we will just quickly give few labels to this. You can go to your labels, you can select single labels, and then you can go to your population density, you can select the text option, you can improve the size, you can also change the, you can also try to change the color of this text. So, I am giving yellow over here, just applying it. This kind of displays what is the density of population in each state. You can also try to add the kilometer square text also to it, which I think you would have been taught in the labeling part of the lecture. We have seen both the mapping techniques. We have seen how an isopleth map works and how a choropleth map works. So from both these techniques, I wanted to just give you a summary of the basic points that we have studied, or basic things that we have studied today. So in terms of an isopleth map, it is basically the lines connecting the locations with the same values. So we saw that with the example of the elevation data. And then when it comes to the choropleth map, it is trying to shade or trying to show different shades to polygon features with a variable. So that variable can be population density, which we saw as an example. It can also be the smoking rate, it can also be the fertility rate. All these things, when you try to proportion it and when you try to give different shades based on this proportion, then it forms you the choropleth map. And then so for doing the isopleth map, basically in QGIS you try to use the contour tool, which helps you to draw these lines that are connecting the points of equal values. And in terms of the choropleth map, you are going to apply the attribute table, the field calculator, and then you are going to use the graduated symbols in your QGIS symbology. Thank you so much. Have a great learning experience.